Hey guys, here's a video showing you how to do C6 for related rates. Looks like we have a conical tank with vertex down. Alright, so we have a cone basically, vertex is down. They tell us it's 10 feet across the top and 12 feet deep. So 10 feet across the top and 12 feet deep. Actually, really, that should probably go to here. Okay, 12 feet deep. Basically this right here. And let's see, what else do they tell us? Water is flowing in the tank at a rate of 10 cubic feet per minute. So the water's going in. So that's my dV dt equals 10 cubic feet per minute. And we're trying to find the rate of change of the depth of the water when the water is 8 feet deep. All right, so that's 8 feet right there. And we're looking for, we'll call that h, I guess. Is 8 feet. And we're looking for dH dt. Question mark, question mark. Okay, so the equation, of course, we're going to use volume. So we know volume for a cone is 1/3 pi r squared times the height. And so that's the volume of the water at any time. The problem is, they don't give us the actual, radius of the water. Or actually, well, the radius, I guess, here we can figure out is 5. But I don't really care. I just need to come up with a way to represent each variable in this equation. So I've got volume, of course. The R, I don't really have anything yet. And the H, of course, is I'm trying to find dH dt. So just like those other cone problems, we need to somehow substitute. I don't want to have two unknowns. So we need to relate R and H somehow and then substitute in. Well, we can use similar triangles. We've got the big triangle here, and we've got the smaller triangle here, essentially. So we can set up a proportion. The 5 over the 12. 5 over 12, right? That's the radius of the cone versus the height of the cone must equal the radius of the water over the height of the water. Okay, so yes, I could find the actual R value, if I needed it. But I don't think I actually need it at this point, but I totally could if I plugged in 8 for H, excuse me. I just need to relate them somehow. So 5H, of course, equals 12R. So R is going to equal 5 over 12H. Now I can take care of that. So the volume is going to be 1/3 pi 5/12 h squared times h. So this h is here. R is 5/12 h. Plug that in. I'm going to clean that up before I differentiate. So this is going to be 1/3 pi 25 1/44 h cubed. Does that look right? I know my derivative, the 3 and the 1/3 are going to cancel out, so I'm just going to leave that there. So dV dt is going to be pi times 25 over 1/44 h squared times dH dt. I know dV, I know h is 8, and dH dt is what I'm trying to solve for. Okay, so let's plug all that in. So 10 is going to equal pi times 25 over 1/44. H is 8 squared times dH dt. So this is 10 equals, what was that, 64? 64 times 25 over 1/44 pi dH dt. So 1/44 times 10 over 64 times 25 times pi equals dH dt. I'm guessing there's some simplifying we could do. Let's see. That's going to be 2 and 5. That's going to be, oh boy, what goes into both of those? 8? 8? Nope. Yeah, I think 8 actually. 8 and then 18. Is that 18, 8, which is also 9 and 4. Alright, so what is that? 9. Oh, and then did I get rid of that yet? So 2 and 2. How about 9 over 2 pi? Does that work? dH dt. I don't have the answer key with me at the moment, but I think it's something like that, and it's got to be feet per minute. If that's wrong, I probably just made a careless error in here, but I'm guessing it's close enough to the point where that's not the part you're having trouble with. I'm guessing it's connecting the H to R. So we did another cone problem like this where they basically told you the height is 3 times the radius, that kind of thing. The only difference here is you had to come up with that connection yourself. Okay, so hopefully that helps with this one. If you have any other questions on that, please let me know. I guess that's that. Okay, stay tuned for more videos.